So hi everyone, this is Chandan and you are watching the learning field. So in this video, we are going to discuss what projection of a vector onto a line and the projection matrix. So how can we find the projection matrix and what is a projection of a vector onto a line and along a line? There are different language are used in these situations. Okay, so basically this is a topic from linear algebra and from inner product space. This is a questions, or this is a topic from basically the chapter of inner product space of linear algebra. Okay, now how can we find projection of a vector and then projection matrix and then characteristics of the projection matrix? See, in the GATE paper and CSIR NET paper, in the recent year in CSIR NET paper also, the question directly based from projection matrix. Okay, there are some questions coming in the exam paper from directly based on this projection matrix. So let's start this lecture, and before starting I am requesting you to all those who are new in my channel, please give a like to this video, share with your friends, and don't forget to subscribe the channel. And one more thing, our target is 10k subscribers as soon as possible. So this is the thing, and if the contents of my channel are helpful for you, then you can definitely give some donations to clicking the thanks option of this channel, and you can also join my channel, okay, for membership. So see, देखो यहाँ पे क्या है कि द प्रोजेक्शन ऑफ अ वेक्टर. सो इफ वी फाइंड दैट द projection of this vector b onto a line a, that is we have to find the projection of this b vector onto a line along a. That means basically we have to find the image of this b vector along this direction a. So now first we comes to some vector concept, and then we comes to the linear algebra, because this is the most easy or easiest explanation to understand this topic or projection of a vector on a line along a line. Now we see here that this is a b vector and this is a vector in that direction. Suppose this is the origin and the b vector passing through origin, and let theta be the angle. So now if this is theta, then we can easily write that this cos theta equal to what? Cos theta equal to OA by mod of b vector. Okay, this is b vector, and we can also here using norm here for the linear algebra concept. Okay, now we write here the modulus. Okay, now that means this OA means what? OA means this OA, this is equal to mod of b into cos theta. Okay, mod of b into cos theta. Now we have to find just this OA vector. Projection of OA vector means image of this b vector onto this a direction. That means what? That means the projection of b vector along a line a vector, or projection of b onto a line a. This language should be also used. So this is equal to what? This is equal to OA is the value of the vector OA into direction vector. Okay, OA into direction vector. Since OA is the image, okay, OA into direction vector. Okay, now this is OA equal to what? OA equal to, we write here, mod of b into cos theta. Okay, mod of b into cos theta, and direction vector means what? This a is the direction vector, so that means we write here a by mod of a. This is the unit direction vector or unit direction vector. Okay, now what is the value of cos theta? If a is the vector in this direction, b is the vector in this direction, then we can definitely write a dot b, this is equal to mod a mod b cos theta. That means from here we can write cos theta equal to mod a mod b by a dot b by mod a into mod b. Okay, now find the value of cos theta here. So this is equal to, or mod b cos theta equal to a dot b by mod a. So we can easily or definitely write a dot b by mod of a into this direction vector, that is a by mod of a. So this is equal to, we can write a dot b by mod of a whole square into a vector. Okay, so this is the direction of b vector along the a vector. Okay, direction of projection of b along a line through a or along a. These are the general language using here. Now this is that is definitely, this is our original case, direction of B vector on A vector. Fine. Now in linear algebra, how can we write this thing? Just in inner product space. Okay. Now here suppose A is a vector which is n vector a1, a2 and an. Okay, that is A belongs to Rn. Then definitely B is also belongs to Rn. Okay, b1, b2 and so on, bn. Okay, belongs to Rn. Okay, then A dot B means, here we write in linear algebra, A dot B means what? We can write in this notation, A dot B. Okay, fine. Now mod of A square, that means in here it is that dimension is only one in vector, or vector means three dimensional. Look, I, j, k, but here in dimension, and we here we can convert this mod to the norm. Okay, that means we can also know that this mod of A square in vector, this is we can write in linear algebra norm of A square. Okay, fine. And A means it, that is A dot B means, suppose if A is this and B is this, then how can this A dot B is possible in linear algebra? We can write this A dot B means what, or B dot A means A transpose B. We can write A transpose B vector. Okay, so A transpose B vector means, or B dot A, if we write B comma A, then that means B A transpose B vector. This is the definition. Okay, so this is equal to, we can write, that is in linear algebra projection of B onto a line A, this is equal to, we definitely write P equal to what, A dot B, that is A transpose B. Okay, into norm of A means what, A transpose into this A. So this is the projection, and we can also write in linear algebra this is A. Okay, that is A. I think I am writing here correctly. Just 1 minute. Yeah, this is the thing. Okay, this is the thing. That is, this is equal also, this X equal to, you can write A transpose B by A transpose. And now since this is a scalar quantity, just a in the vector this is a scalar quantity, and in linear algebra this is just a constant. Okay, now this is a constant and this is a vector in vector space, n dimensional vector space. Therefore we can easily write this P equal to A into X instead of X into A, because X is a scalar quantity. So we can write A into A transpose B by A transpose. Okay, now since this is also a vector, then A transpose multiplication is also possible. So we can write A transpose by A transpose by sorry, just a second, this is A transpose A, otherwise it is a matrix A transpose A, sorry, this is A transpose A. Okay, see, A transpose A means what, A is a column vector. Suppose A equal to A1 A2. Okay, then A transpose A means what, A transpose A, this is equal to A1 A2 into A1 A2. Only when we write it in this way, then only the multiplication of possible in vector space. Okay, the two vector multiplication means what, A transpose A, exactly. Okay, so this is equal to A transpose A into, we can write this is B vector, because this is just a scalar quantity. Okay, this is not this is A transpose A. Okay, so this is equal to, we can write P into B. Okay, so this P equal to, projection equal to capital P into B, and this capital P is called the projection matrix. Fine. So we start from vector, then we comes to linear algebra, and then we definitely we can we are reaching now in projection matrix. Okay, now we taking here the examples. Okay, first we take an example. I think you will understand definitely this topic, because this is a very interesting topic. Okay, now if we take a vector B, so projection matrix, I erase this thing. Okay, so if we write, or if we find B equal to 1 2 3 1 2 3 and A equal to 1 4 7, so if we need to find the projection of this B vector along A vector, then what is the case? So projection of B on A, this is equal to what? This is the formula. What is the formula? Or if we find the projection matrix capital P, just a minute, first we find the projection matrix capital P, this is equal to A transpose by A transpose by A transpose A into B vector. Okay, so this is equal to, always remember the vector terms, and then it is definitely easy to remember the linear algebra concept. Okay, because if you just using some general concept of multiplication of vectors in linear algebra or vector space, then you can definitely derive this formula, or you can definitely remember this formula. So this is equal to A transpose means what? First we convert the A transpose A. So this is equal to 147 and 147. See, if we don't write in this thing A transpose A, then the multiplication is not possible. Okay, always remember this denominator term gives you a normal scalar quantity, and this numerator terms gives you a matrix. Then you can definitely derive the matrix in a very easy manner. Okay, so this is equal to 1 into 1, 1 plus 16 plus 49. So this is equal to basically 66. Now we find the A transpose. So A transpose means, see, A means 147 and A transpose means 147. So this is a 3 by 1 and this is a 1 by 3 matrix. So this will give you a 3 by 3 matrix. Okay, now we just find 147 first, 147, then 4, 16, 28, then 7, 28 and 49. So this is the matrix. Now what is P? So this is P equal to what? A transpose by A transpose A. This is equal to 1 by 66, I think. 1 by 66 A transpose A. No, I think I am getting wrong. Just a second. A transpose B. Oh, sorry. P means what? P means A transpose B. A transpose by A transpose A. Okay, is the projection matrix? Yes. We are going to projection matrix. Okay, correct. 1 by 66 into 1, 4, 7, 4, 16, 28 and 7, 28 and 49. So this is the projection matrix. Now what is the projection of B on A? So projection of B on A means what? Projection of B means A. This is equal to, we can write from this vector, this one, P equal to AX or AXX. So A transpose B means what? Now projection, we can find projection matrix, we find that. So projection of B on or along A, this is equal to what? Projection of B along A, this is equal to A transpose B by A transpose A. This formula, this is the X is the is case. Okay, so projection, this is the projection P equal to, so A transpose B by A transpose A. So this is equal to A transpose B means what? A transpose B means A transpose A, and A transpose A means here 66. So 1 by 66 into A transpose means 1, A transpose means 147 and B means 1, 2, 3. So this is equal to 1 by 66 into 1 plus 8 plus 21. So this is 30 upon 66. This is equal to what? 6, 5 upon 11. Okay, 5 upon 11 into, we have to write the A vector. Okay, so A equal, that is projection equal to, this is not the projection, projection equal to P equal to, this is the value X. Okay, X into A vector, sorry, X into A. Yeah, so X into A means 5 by 11 into A vector means what? A vector means 147. So this is the projection, this is the required projection, and this is the projection matrix. Okay, so I'll clear once. So this is P equal to x into A. Okay, P equal to x into A. This will give you the projection small p. Okay, small p give you the projection, and this formula is A transpose B by A transpose A into A vector. You just remember the formula in vector: A dot projection of B vector along A vector, B dot A by A dot A into A. This is the formula. Okay, and you just see here the whether the vector multiplication in n-dimensional vector multiplication is defined. Okay, you just need to this thing. Now there are 2 or 3 characteristics of this projection matrix. Okay, characteristics of projection matrix. I think this will be clear for you. Now some characteristics or properties, you can say. Okay, number 1, this P, capital P, is a rank 1 matrix. Okay, that is always the rank of the projection matrix should be 1. Okay, from this statement you can definitely, or in the CSIR NET exam recently you see the questions regarding the you have given, then you have to check whether this is a projection matrix or not. These types of questions mixedly asked in the paper. Okay, and this is a symmetric matrix, always a symmetric matrix. Okay, number 2, and number 3, projecting a second time does not change anything. See, P equal to, or yes, P x into A. So this is the projection. Now if we project this vector second time, then there is no change. Okay, that is basically it saying that P square equal to P. You can also saying that P is an idempotent matrix. Sorry, P square equal to P means what is the name? So P square equal to P, this is the case. Okay, so I think idempotent. So these 3 are the main properties of the projection matrix P. Okay, so this is the class for today. I think you will understand what is the projection vector, how can we calculate the projection vector onto a line, and the projection matrix if a vector project in another line, then what is the projection and what is the projection matrix, and how can we calculate these 2 things with examples, and the properties of the projection matrix is here. Okay, projection matrix based questions comes in the exams in the recent year. I think 2020 and 2022 May questions are the from this projection matrix. Okay, so this ends today's class. So hope you are enjoying the learning. So if this video is helpful for you, then definitely give a like to this video, share with your friends, and don't forget to subscribe the channel. And in the next video we are going to discuss again another lecture, projection of a vector onto a space. Okay, onto a vector space. So how can we project a vector onto a vector space, and the projection matrix with the with that case. Okay, in that case. Okay, so thank you, bye, Hare Krishna.